All right, so we're looking at conjugate of a complex number. And so if you see a Z and with that star in superscript, or a Z with a dash over it, you'll read that as the conjugate of Z or Z conjugate. Now, if A is the complex number, if Z is the complex number A plus BI, Z conjugate would be A minus BI. It's also true that if Z is the complex number A minus BI, Z conjugate would be A plus BI. All right, so a complex number and its conjugate, they're almost identical. The only difference is that the sign of the imaginary part of the complex number will be different. All right, so properties of a conjugate of the conjugate. So the product of a complex number and its conjugate is the real part squared plus the imaginary part squared. So all that this is simply saying is that if Z is the complex number, let us say A plus BI, Z times Z conjugate would be equal to A square plus B square. So that's what it is saying. That a complex number multiplied by its conjugate is the real part squared plus the imaginary part squared. That's all it is saying. This says that the sum of a complex number and its conjugate is equal to 2 times the real part. So all that this is saying is that using the same example, Z is equal to B plus AI. This is saying that Z plus Z conjugate would be equal to 2 times the real part, so it's 2A. And Z minus Z conjugate would be equal to 2 times the imaginary part times I. So this is going to be 2BI. It's nothing special. I personally don't consider it to be anything special. It's something that you should easily find out for yourself. Was it Jamila? You wanted to ask a question?
Yes,
or say something?
When you times Z by its conjugate, what happened to the I in the equation?
It's going to be eliminated. And it's from the point of view, if you remember, if you multiply 2 binomials, you get, if you multiply this binomial A plus B multiplied by A minus B, your final answer is going to be what? A square minus B square. Because the middle part would have been what? Eliminated. A similar thing would happen if you multiply a complex number and its conjugate. The imaginary part is going to be eliminated. You could easily try that for yourself and see it for yourself that it is true. Let me erase here. Any other questions? All right, so let's have a look at example 6. So example 6 says, and you can see, I don't want anybody to turn the thing into a formula, because you can simply work out these things on your own. You don't have to try and remember what it said in the notes. You understand? Just simply work it out for yourself. So we have Z1, example 6 says Z1 is 3 plus 4i, and Z2 is 2 minus 3i. We are to find Z1 plus the conjugate of Z1. So here, that this would be simply Z1, which is 3 plus 4i, plus the conjugate of Z1, which is 3 minus 4i. All right, so if I add them, I'm going to get what? 3 plus 3 is 6. And 4i plus minus 4i would be 0. So that should be clear. All right, guys, I'm going to pause the video. Then I want you to do the rest of example 6. and then I will finish it up. All right, so guys, you can complete the rest of example 6 on your own. Based on how you guys have been moving, I don't foresee it would be any problems to you. So let's have a look at division of complex numbers. So this says division of complex numbers. It says make the denominator real by multiplying the numerator and the denominator by the conjugate of the denominator. All right, so with that in mind, example 7 says, given that Z1 is 2 plus 4i and Z2 is 1 minus I, we're to find the complex number Z1 divided by Z2. So Z1 divided by Z2.
So sorry to stop you. You said you'll be going back so we can write out the last 3 examples?
No, I won't go back, but I will send the notes to you via WhatsApp when we're finished. Is that okay?
Okay, no problem.
All right. So this is going to be 2 plus 4i divided by 1 minus I. And we're dividing by a complex number. And we're told that the way we should approach this is that we should multiply the numerator and the denominator by the conjugate of the denominator. So I'm going to multiply this by 1 plus I, because 1 plus I is the conjugate of the denominator, and multiply the bottom also by 1 plus I. So if we did that, we're going to end up with multiplied binomials. 2 times 1 is 2. 2 times I is 2i. 4i times 1 is 4i. And 4i times I is 4i squared. So I just multiply the 2 binomials at the top, and I'm going to do the same thing at the bottom. Now, the bottom will result in the difference of 2 squares. If you have 1 minus I multiplied by 1 plus I, the answer is going to be the difference of 2 squared. So your answer is really going to be 1 squared minus I squared. All right. So at the top, I'm going to have 2 minus 4. And 2i plus 4i is 6i. At the bottom, I'm going to have 1 squared is 1 minus I squared. I squared is minus 1. So it's minus 1. So what I would end up with is at the top, I have minus 2 plus 6i. And at the bottom, I would have 2. And so our final answer, Z1 divided by Z2, is going to be minus 1 plus 3i. All right, guys. So we're learning how to divide by a complex number. And what we had to bear in mind is that the way we approach it is we're going to multiply both the numerator and the denominator by the conjugate of the denominator. Now, by doing that, the denominator is going to turn out to become a real number. And so you just follow through until you get your final answer. All right.
So could you scroll up so to see the definition of division of complex?
No problem, but I don't think I want to do that because of the limited time. Okay. Just bear in mind, guys, I'm going to send it to you. I just want to move on to 8.
Okay, sir.
All right, 8. We have Z. All right, I think I need to work part of 8. Let me work Z squared. So I'll work A for 8. You should be able to manage B after I do A. So I'm turning the page. So I have Z, and I need to find Z squared. So first of all, what I would do is I would work out what Z is. Z is 1 plus 2i divided by 2 minus I. So the way to simplify this is to multiply both the numerator and the denominator by the conjugate of the denominator. So it's going to be multiplied by 2 plus I and multiplied by 2 plus I at the bottom as well. At the top, 1 times 2 is 2, 1 times I is I. Multiplying two binomials, 2i times 2 is 4i, and 2i times I is 2i squared. The bottom is going to work out to be the difference of two squares. So this is going to be 2 squared minus I squared. The top is going to be 2 minus 2. All right, and that minus 2 is coming from here. That's 2 times I squared. I squared is minus 1. 2 times minus 1 is minus 2. And I plus 4i is 5i. Down by the bottom, this is 4 minus 1. So what I'm left with is 5i, and at the bottom, 5. So the complex number z, which is 1 plus 2i, divided by 2 minus I, that complex number works out to be just I. So it means that z is just the complex number I. So once I know what z is, I can easily work out the next part of the question, which is z minus 1 over z. We can go back to just double check. Z minus 1 over z, which would be I minus 1 over I. Should not be an issue. All right, so this is the penultimate thing, and we should not leave here today unless we know how to do this. It's more lengthy than difficult. It's more lengthy than difficult. I'm going to stop the video here, then I'm going to start over the video because I don't want the videos to be too lengthy.